Hello, everyone. My name is Sohail, and I'm a PhD research fellow at Media Futures. I'm associated with Work Packy 3, Media Content Analysis and Production. And I'm working with Tian, who's my supervisor, and my co-supervisors are Andreas Optal, Fadler and Christoph Retner. As first, they give some background information about myself, then I move on from this. So the main motivation for today's presentation is like I'm talking about visual content verification, but mainly I'm talking about my PhD plan because I would like to get some very useful suggestions and feedback from the industrial partners, and I want to let them know what I'm working on and if it's according to what they are expecting me to do. So yeah, and also I would like to request the industrial partners to propose an industrial supervisor for me as well, because in that way we will have a very fruitful collaboration, and then I will be able to understand what they are expecting of me, so that I just fulfill their expectations during my PhD. Moving on towards my presentation, I would like to talk about my research plan, and I have these three research questions which I would like to answer during my 3 years PhD research. The research question one is basically I
Sorry
would
to
like to
interrupt you so high, but I think we only see your first slide, so maybe you share a wrong
oh
screen.
okay. Can you see now?
Yes.
Okay, sorry about that. I didn't know about. So I will talk about my research questions which I would like to answer during my 3 years PhD. And first one is basically I would like to understand how multimedia content verification is carried out in media industry. And then the second one is how can we fight deepfake media within the news domain? And the third one is how can we fight deepfake media within the news domain? I will talk more about these in detail in upcoming slides. Uh, yeah, so before I go on into the presentation, I think most of you are familiar with these 7 common forms of information disorder. So this is a list proposed by Claire Wardle, who is an expert on user-generated content verification and misinformation. She proposed these 7 forms of information disorder which we encounter online. I'll focus mainly on 4 of these because these are considered to be more widespread and considered to be more manipulative towards the audience. I will give examples of each of these from news domain. So coming up with the first one, this photo is very popular, and this was shared by the Iran's defense ministry when they conducted some missile tests. And but afterwards, it was found out that this photo was manipulated, and one of the missiles in reality didn't fire, but they tried to conceal it and then manipulated the image and then shared this image. And this falls into the manipulated content category on the information disorder list, um, which basically means is like when the genuine images like these are tempered to manipulate the audience or with an intent to cause harm in some cases as well. The next one is a more recent one. So this is a painting generated by generative adversarial networks, which is a form of artificial intelligence and deep learning. So this painting was generated totally by the AI algorithms, and this falls into the category of fabricated content. Here, it doesn't cause any harm, but it has a potential. And this painting was sold for more than $400,000. Even it is generated by AI, but it was sold for more than $400,000, which is like 45 times higher than the market price of this photo, this painting. Then the next on the information disorder list is false context. It is when genuine images which are not tempered are shared with false contextual information, which we can see here. we see two different tweets. One saying that these two children are from Nepal, and then the other one saying that these are from Myanmar. But in reality, uh, the photographer, the photographer of this photo, shared on Twitter that it is a photo from Vietnam, and it is being shared with false context widely on the internet. And then on the fourth one on the information disorder list is false connection. It's when we see clickbaits on websites. So when headlines or news captions do not match the content of the article, like here it says, scientists create a new cowpox style virus that can kill every type of cancer. And but when you look closely, scientists are hoping. So this is this is creating a false connection between the article and then the headline. And this is definitely to misrepresent the information present within the article and cause created to manipulate the audience. I will talk about some of the tools which are being used to verify this kind of content which we find online, and there are a lot of tools. Some of the more widely used are highlighted here, and I will give examples of this tool in upcoming slides. So I downloaded an image from internet, which is this one, and then I did some manipulations, like the basic ones. I copy pasted this image region from here to here, and then I spliced a tree from another image in here and here, and then I used this tool to check if it is able to detect these forgeries or not. And when I tested it, it uh, found out that okay, these two regions are copy pasted, which is correct. And then when I did an error level analysis, it shows that okay, this region is different from all of the other image. It will be better seen when we zoom into it, but unfortunately on these slides I cannot zoom in. But here we have this thing. But then a problem arises when we compress the images. So when I compressed the image 2-3 times, it became more noisy, and then we cannot differentiate between this area where I spliced. However, it is still able to detect the copy paste forgery. But then I manipulated this image again, and then I used this brush tool and around this copy pasted area, and then when I gave it to this tool, it was unable to detect this. So the main purpose of this is to show that these tools work in some cases, but when the images are manipulated uh, and compressed 2-3 times, this tool will not work in most of the cases. And then I did a reverse image search for the photo, and then I found different versions of this photo, which is very useful for the journalist if they want to find out, okay, if this image is manipulated or not. But sometimes when the image is newly generated and it is not shared on the internet before, it becomes problematic to verify these kind of images. So this comes towards the sub-research questions, which I would like to answer uh, during my research, and which will eventually answer the research question. One is I will I have started so I've started this one. So I'm looking at the state of the art in multimedia verification in journalism, like what tools journalists use and what are their limitations. And then I plan to create a repository of the tools and papers, which will be helpful for journalists and everyone who want to have all of these tools at one place. Moving towards the research question two, how can we fight defects within the news domain? I will talk about this now. So this is a really good illustration which discriminates between the defects and defects, which says that the defects are generated by computer algorithms requiring more technical know-how and resources. And this is a new form of manipulation which is not very widespread on the internet. And then the defects, which are more widespread than the defects at the moment, because they are less, they require less expertise and a few technical resources to create these kind of things. So defects can be anything. generated using deep neural networks. We have a few examples here, like these images were generated using deep neural networks, and they are capable of doing almost everything. Like they can generate images from text. They can they can be used for fast swapping. They can be used to convert text to video as well. So they have a lot of useful use cases, but then they are used for to spread misinformation and disinformation as well. And mostly in this case, the defects we have now are used for fast swapping. We have a few examples from the recent times of the deepfakes. Like all of these here are deepfake videos of some celebrities and politicians, and these are quite recent. And then if we see at the look at these videos, they are quite realistic, and this is what is very dangerous about deepfakes, because they look really realistic and difficult to detect these kind of manipulations. And this video was recently shared on TikTok, and the person who shared this video on TikTok, they ended up creating a company out of it, and now they create commercials for big brands like Gillette, and so these are becoming more widespread now. So I will talk about how the defects are generated. So this is a very basic architecture of how the defects are generated. So we have one network which is used to generate images, and then one network which is called discriminator, who discriminates the images generated by generator, and then the images from the training set. And whenever the discriminator says, okay, this image is generated by generator, the generator then generates the image again and then feeds to the discriminator. And it does until the discriminator wrongly classifies this image as real. So this is a basic structure of how defects are generated. Moving on towards the detection of defects, there have been a lot of studies in the past which were proposed to detect defects. Some of them they work by finding out the face warping artifacts around the faces, like the we find here compression and this square around the face. But now more new defects, they don't have these kind of artifacts, so these kind of approaches do not work for the newer defects. And then also one study was proposed which was able to detect defects by uh, looking at the head poses of different celebrities. But these videos cannot this kind of detection strategies cannot work for people we don't have any prior information about, and maybe they can only work for in case of celebrities or politicians or well-known persons, but not ordinary persons. Other techniques which were employed to detect defects involved uh, looking at eyes. So one study found out that the videos generated using GANs, the characters, they do not blink their eyes. So they proposed an algorithm which tracked the eyes of the person in the video, and um, then found out that okay, this if this is a defect or not. And then there are some other in older defects, there were some other inconsistencies like different eye colors, which can be seen here, or reflection details when we look closer at the eyes, and the shading around the nose of different facial parts. Some other defects detection algorithms, they work by detecting whether the image generated by GANs has uh, any kind of fingerprint or not. But now, if the research found out afterwards found out that if the images are compressed, then the detection does not work, because now when the image is compressed, the fingerprints get destroyed as well. And now the defects are getting better as well. So when we look at older defects, they sometimes had these kind of artifacts on their swapped areas. But when we look at the newer ones, they don't have anything. So in this case, we are looking for fast swapping, where the faces of two persons are swapped. And here in facial reenactment, we see that the quality is also improving as well. And as it was the case with the image forensics, where the compression hurt the detection, in defects, compression also plays an important role. And here we see that when we compress images, the detection quality uh, comes down as well. So for low quality images, the same algorithm was able to detect only 81% of the time. So compression here plays an important role as well. So now, in research question two, I will work step by step on the sub research questions. So I will study how the what is the state of the art in defect detection, and how can we make the defect detection system more robust against compression and other stuff, and more generalizable. And also, how can we address and improve the defect detection in use domain, which is really important. Now I'll talk about the research question three. How can we fight defects within the news domain? So defect is a form of audio or visual manipulation, which is created using cheaper and more accessible software. For example, Photoshop, or defects can be in the form of like edited images, like we can see here. So this image is Photoshop, and it falls into the category of defects. And then here we see frame rate alteration, forgery. So basically, this slows down the image, and this footage was slowed down uh, to make Nancy Pelosi appear ill or drunk. So this is also a kind of cheap fake, which is really easy to generate. And then the recontextualizing, the example which we have seen before as well. Detecting defects is also quite a challenging task, and it is somewhat similar to fact checking in text, but in this case, the text and the image can be can be real and factually correct, but then presented out of context. So this causes a bit of problem in detecting this visual and textual uh, defects. And Technical University of Munich, in their paper Cosmos, they proposed a data set to detect these kind of forgeries, where they released more than 200,000 images and their associated 400,000 captions. And they also proposed a strategy to detect defects, where they have an image encoder which works for images, and then two textual encoders which encode the false and the real caption. And then they do this analysis and find out, okay, if this image is presented out of context or not. But still, it's a really difficult task, and their algorithm, it achieved only around 80% of accuracy on the training set, and they did not tested it on other data sets. And if presented with real world examples, this might not do well, as it is the case with other algorithms as well. So in research question three, I would like to study what's the state of the art in defect detection, and I would also like to study whether using different models for images and text data is useful, or whether using a single model like transformer architectures, which can work on image and text simultaneously. So I would like to uh, do this as well during my research. And also then the most important one is how can we address and improve defect detection in the news domain. So here is my basic work plan, which I'm following. So the first is I would like to collaborate and speak with the industrial partners to understand their expectations and requirements. And I really would like to have their feedback on my research. And also I would like them to also propose an industrial supervisor who can, with whom I can work. And also I'm looking for internships within the industry partners to better understand their workflows and requirements from this project. So what they want from this project, it will be really beneficial for me. And first, so the first research question is visual content verification in journalism. So this is what I'm working on. And then Then after having an answer for this one, I'll move on to the next research question for defect media detection, which I plan to work on at the end of my first year and at the beginning of my second year until the mid of my second year. And then from there on, I will work on defect media detection. And in that, I would like to collaborate with the task 3.1 and 3.4 in our work package 3 because they are working on similar topic of content verification and fake news detection. They are mostly focusing on text, and I will focus on both images and text. So I think the collaboration will result in some good research. So here I have some planned deliverables. It is very early to talk about these, but I have these things planned. So the result from my first research question will be an online repository, maybe on GitHub, where I will summarize all of the available tools and the research papers on how the multimedia content is verified in the media industry. And I will keep on updating this to make it up to date with the time. And for the research question too, I plan to have a defect detector uh, which can be incorporated into the industrial workflow. So the industry partners can use it to look on videos and find out whether they are real or deepfake. And then also a defect detector as well, which will be available for the industry partners to incorporate into their workflows. I will talk about my publication plan. So at the end of this research, I plan to have around 4 to 5 publications, uh, two survey papers, and then two conference papers. One from multimedia content verification in journalism, which I'm working on at the moment, and then one or two from defect media detection, and then one or two from defect media detection. This was all from my side, and now I would like to have any valuable suggestions from industry partners and other audience in their comments.